Okay, boys and girls, we are going to learn how to multiply fractions. To start with, we are going to use a tape diagram. We're going to draw and label the tape diagram to prove that this statement is true. We're going to show that 8/5 is equal to 4 times 2/5. And you notice we have it in unit form. So let's first start off by labeling our tape diagram with 8/5. So let's see, there's 1, 2, 3, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8/5. I know that this whole tape diagram represents 8/5. One thing I also know is that it takes 5/5 to make one whole. So I'm going to just shade 5/5. There's 2, 3, 4, 5. You do not have to shade yours, but you can. And I just want to note that this is actually one whole. So that leaves me with 3/5 left over. So another way of saying 8/5 is to say 8/5 is equal to one whole and 3/5 left over. Because I have my 5/5 here. 5/5 is the same as one whole, and that was 3/5. 5/5 plus 3/5 is 8/5, so that is the same as one whole and 3/5. Now it says I have to show how 4 groups of 2/5 would be equal to 8/5. So I'm going to make 4 groups of 2/5. Here are 2/5. Here are 2/5. And if you have trouble making the little bracket, like I'm just making it squiggly, I don't really care. You can just make a little V shape. 2/5. So I have 1, 2, 3, 4 groups of 2/5. And that is the same as saying I have 2/5 plus 2/5 plus 2/5 plus 2/5, because I know that multiplication is the same as division. I'm sorry, multiplication is the same as repeated addition. So 4 groups of 2/5 is equal to 2, 4, 6, 8/5. If I wrote this out this way, 4 times 2/5, that would equal 8/5. Or it would equal 8/5. I'm wondering if you can see a relationship anywhere with these three numbers where I could get an 8 and a 5. Hopefully you're noticing that 4 times 2 is 8, and then I just use 5 units because that's how many units are in one whole. I don't change the unit when I multiply, when I'm showing 4 whole times 2/5. Okay, so let's try 10/6. So we're going to make 5 cuts. 1, 2, 3, 4, 5. So I should have one. Oh, wait, sorry. I need 10/6. So there's 5. I'm just going to cut those all in half again. Now I should have 10 pieces that are cut into 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh man, I made so many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I had a little bit extra, so I need to erase. Sorry about that, you guys. At least you can see that I make mistakes too. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6. Now, so this is my 10/6. How many 6 make one whole? I know it takes 6 6 to make one whole. So there's 1, 2, 3, 4, 5, 6. So there's my 1 whole. And then I would have 1, 2, 3, 4, 6 left over. So I'm going to make it a different color so you can see it. So the leftover piece is 4 6. So right now what I know is that 10 sixths is equal to 1 whole and 4 sixths. But I also need to prove that it is equal to 5 groups of 2 sixths. So I need to make 2 6, and these parentheses show me how many I'm going to put in a bracket. So 2 6 plus 2 6 plus 2 6 plus 2 6 plus 2 6. So there's 1, 2, 3, 4, 5 groups of 2 6. So 5 times 2 6 equals, and if I use what I learned up here, or I multiply the whole number, 5 groups of 2 equals 10 sixths, or in uniform 10 sixths, which matches our statement B. Okay, we're going to write this expression in unit form and solve it. So I have 7 times 2, and here's my unit. That's the one we're going to turn into words. 2/3 equals, what is 7 times 2? 14 thirds. And in standard form, it would look like that. 4 times 2/4, so we have to show 4 times, whoops, I can write the multiplication symbol. 4 times 2, and then the unit is fourths. So that's the one that we're going to write out. So 4 times 2 equals 8 fourths. Or in fraction form, it looks like that. Pause if you need to catch up. Let's try 16 times 3, and the unit is 8ths. So that's the one I need to spell out. So if you don't remember 16 times 3, or you don't know how to do that, let's do partial product. 3 times 6 is 18. 3 times 10 is 30. That's 48. So you should have 48 eighths, or 48 eighths. This is 6 times 5 eighths. Here's our unit form. 6 times 5 is 30 eighths. We don't change the unit. 30 eighths looks like that. Okay, pause if you need to. We're going to go back to these. So let's just use the shortcut. Instead of changing this to unit form, why don't I go ahead and write that as my fraction on all of these problems? Because I know that's the unit size that I'm working with. Boom. Done. Pause if you need to catch up. Now I know I need 7 groups of 4/9. 7 times 4 is 28. I need 6 groups of 3. 6, 12, 18. Okay, that's 18 fifths. 8 groups of 3/4. 3, 6, 9, 12, 15, 18, 21, 24 fourths. 6 groups of 3/8. 6 times 3 up above was 18. 10 groups of 7/10. 10 times 7 would be 70. 3 groups of 4/100 would be 12/100. Now, one thing you can do to take this to the next level is realize that this is an improper fraction. whenever we have an improper fraction, we should rename it to see how many whole ninths could I make and how many would be left over. So if I skip count by 9, I would have 9, 18, 27. That would be equal to 3 whole. 27 ninths is the same as 3 whole. And that would give me 1 ninth left over because 27 plus 1 is 28. Then I would be turning these into a mixed number. So let's see how many whole groups of 5 we can take out. We have 18. So we could take out 5, 10, 15. So that would be 15 fifths, which is equal to 3 whole. And that would be 3 fifths left over. Okay, this is thinking back a couple lessons. We have 24 fourths. Let's see if we can make, how many groups of 4 can we get out of 24? So let's skip count. 4, 8, 12, 16, 20, 24. Ooh, that's 6 whole, and there are none left over. So I can make 6 whole out of that. Let's do 18. 18 times 1 is 8. Oh, I'm sorry, 8. 8 times 1 is 8. 8 times 2 is 16. So 16 eighths would be the most eighths that I could put out. That would give me 2 whole. And I would have 2 eighths left over. 70 tenths. Let's see, if I skip count by 10s, 70 tenths. Oh, that I could do that 7 times. So 70 tenths is equal to 7 whole. And then 12th 100ths, that's not improper. I can leave it that way. The last problem says that Maria needs 3 fifths of a yard of fabric for each costume. How many yards of fabric does she need for 6 costumes? So she's going to do 3 fifths plus 3 fifths plus 3 fifths, which she would do that 6 times. Or I could do 6 times 3 fifths because she needs 3 fifths for each one. So let's use our trick. We know the denominator is going to be 5. We're not changing the unit size. But she's going to have 6 groups of 3 fifths. So 3 times 6 is 18 fifths. So how many yards of fabric does she need? Let's turn this into a mixed number. How many groups of 5 can we take out of 18? 5, 10, 15. That would be 3 whole yards with 3 fifths of a yard left over.